Hi, I'm Robin Haller. I'm an artist who specializes in digital design and weaving. In the last few months, I've spent over 200 hours completing a weaving project that combined both digital design and industrial technology. My goal is to bring more awareness to the innovations of contemporary textile arts. The preparation of the materials and setting up the loom often takes more time than the actual weaving of the cloth itself. As part of my research, I explored the idea that the process is just as important as the finished piece itself. Receiving the Regional Artist Grant allowed me to purchase the necessary equipment to document my process through a time-lapse video. The Textile Art Studio at Kent State University allowed me to come in and use their equipment and dye studio, as well as weave on their TC1 hand-jacquard loom. What took over 200 hours to create is condensed into a 15-minute video. Enjoy this presentation of the world's fastest weaver. Winding the warp. The warp, or vertical threads of a weaving, are individually wound on a warping board to prepare for dyeing. Around 1,760 warp threads are needed for this project. Dyeing the warp. The warp bundles are painted with thickened dye in a gradient of color. Once dyed, the yarns are wrapped in plastic to cure overnight. Skeining the weft. The weft, or horizontal threads of a weaving, must be sequentially wound before dyeing. Rinsing the warp. The dyed warp is carefully washed and rinsed by hand to remove the excess dye, and air dried before setting up the loom. Mixing dyes for weft. While the warp yarns soak during the washing and rinsing process, the dyes are prepared for the weft yarns. Dyeing the weft. The skeins of weft yarn are dyed using an immersion dye method. They are washed and rinsed in a similar fashion as the warp yarns. Balling the weft. The weft yarn must be balled up before being able to weave with it. This weaving was created on a TC1 thread controller loom. It is a computer-assisted loom that individually controls each warp thread, allowing for freedom from the repeat across the width of the loom. Tying on the warp. Each warp thread is individually tied onto the existing warp of the loom. This allows for the complicated sequencing of threads to remain in order as the warp is wound back. Warping the loom. Once the threads are tied, the knots are carefully pulled through the reed and the heddles. Slowly, the warp is wound onto the back of the loom. The threads are then bundled and tied onto the front of the loom. Weaving. The design for the weaving is opened in the specialized weaving software. The program translates the weave structures as binary code. The loom reads the code. Red equals warp up, white equals warp down. As the weaver steps on the single pedal of the loom, it signals the computer to read the next line of binary code and send the sequence to the loom. When the heddles raise and lower, the weaver throws the shuttle with the weft yarn and beats down the weft yarn, creating a row of woven material. Blocking the weaving. The finished weaving is cut from the loom and the dimensions are drawn on a prepared surface. With the back of the weaving facing out, it is pinned along the hems and selvages, sprayed with water, and allowed to air dry. Backing the weaving. The weaving, while remaining pinned, is backed with fusible interfacing to protect the warp and weft floats and to stabilize the entire surface. Hemming. All 4 sides of the weaving are hemmed to the back of the weaving. A strip of Velcro is sewn at the top as part of the hanging device.